Another strategy we can use in non-right angle triangles is the cosine rule. So if the sine rule doesn't work, if we don't have pairs of opposites, we may be able to use the cosine rule instead. So the cosine rule formula is a squared equals b squared plus c squared minus 2bc times cosine of a. Now again, it's important to remember that side of a is opposite angle big A. So the angle here must be, the side here must be opposite the angle here. So whichever side we are putting here, or whichever angle we are using here, must be opposites. The other thing is angle A, or angle here, must be between these two sides, which follows from what I've said before. So in order to use the cosine rule, if we're finding a side, we need what I call an angle sandwich, or two sides and the angle between. So something like this. So if we needed to find that side there, we need to have the two sides sandwiching the opposite angle, as well as the opposite angle itself. So let's do an example. Here I need to find the side x, so I have the opposite angle and I have the two sides that sandwich it, so I have enough information. So I'm going to write down my formula first. A squared equals b squared plus c squared minus 2bc times cosine of a. I might put that in brackets just to make it clear. I'm going to start labeling. So I have A is the one I want. So actually the angle A is there, and that must be the angle, the side A, because it's opposite. And then B and C are the other two sides. So let's start filling in. Instead of A, I'm going to write X. B is 8. C is 5. So again, B is 8. C is 5, and the angle this time is 61. So again, I can fill all of this into my calculator to give me what x squared is. So that's 8 squared plus 5 squared minus 2 times 8 times 5 times the cosine of 61. Make sure to close any brackets if you need to. I have a syntax error, so I've forgotten to, I actually pressed the wrong button here. So 8 squared plus 5 squared. And I get 50.2152. Now don't round just yet because we're not finished. We have x squared, but we need to find x. So to get x, we need to square root both sides to get rid of the squared. So x is the square root of all of that stuff, which in my calculator gives me 7.0862 with more decimals. So if I'm going to one decimal place, that's approximately 7.1. Again, make sure your calculator is set to degrees and make sure you close any brackets you need to close. Okay, let's do another example. So I'm looking for the side x, and I have an angle sandwich there with the opposite angle, so I can use the cosine rule. So a squared equals b squared plus c squared minus 2bc times the cosine of the angle A. I'm going to start labeling. So this is my angle A, so this must be side A, and the other two sides are B and C. It doesn't actually matter which one we call which. Let's start filling in. So A again is x, B this time is 10, C is 15. So again 10 and 15, and this time cosine of 38. So once more in my calculator, if I do all of that stuff, I get 10 squared plus 15 squared minus 2 times 10 times 15 times cosine of 38. Close my bracket again, and I've got 88.596. Okay, but to get x, we need to square root all that. So x will be the square root of my answer, which is 9.0 0.412. Or if I'm going to one decimal place, let's say 9.4. So here's an example for you to try. Let's pause the video and see how you get on. So let's start labeling. That's my angle A, so this must be side A. Here is B and C. So I'm going to start filling in. A squared is x squared, B is 7, C is 8. So minus 2 times B times C, so 7 times 8, times cosine of the angle, which is 43 in this case. Again, x is going to be the square root of whatever I get here, so 7 squared plus 8 squared minus 2 times 7 times 8 times cosine of 43, and close the bracket, is 31.0883. So the square root of all of that is 5.575, and so on. So again, I don't have any rounding specified here, but I'll go to one decimal place, which is 5.6. So that is using the cosine rule to find a side. Now, if I want to find an angle, I can use the cosine rule as well. But to make it a little bit easier, we're going to have to do a lot of rearranging. So let's just have a quick look at the formula. A squared equals B squared plus C squared minus 2BC and cosine. And finally I get to the angle A. So if I want to get A by itself, I could fill into this formula and then do loads of algebra to solve the equation. But let's have a look at the equation itself first. So if I want to get the angle, I need that A by itself. Okay, or for now I'll be happy enough if I get this bit by itself, because then there's only one step to the end. So I want to get all of that by itself. Now at the minute it's stuck with this term here, it's all being multiplied. So let's get rid of the B squared and C squared. So I'm going to subtract B squared and C squared from both sides, and I have A squared minus B squared minus C squared equals negative 2BC times cosine of A. Okay, so now I can deal with the multiplication. Negative 2BC times cosine of A, this is what I want to be left with, so let's divide by negative 2BC. We've got A squared minus B squared minus C squared divided by negative 2BC, and that gives me the cosine of my angle A. So to get my answer, I could inverse cosine, but I'm happy enough with that as the way it is. It's nice and clean rather than having an inverse cosine with a big bracket like that. Okay, I find this is a little bit cleaner. But one problem I do want to get rid of is at the bottom of the fraction I have negative 2BC. So I want that to be a positive, it would be easier to deal with. So I'm going to multiply the bottom by negative 1, so I must do the same to the top. Then I get negative A squared plus B squared plus C squared over positive 2BC equals cosine of A. Okay, but let's just rearrange this to make it a little bit cleaner again. So I'm just going to start with my cosine of A. And that is equal to B squared first plus C squared. And I'm just going to put the negative A squared to the end. Okay, so now I have a formula I can use to find the angle. Once I fill into this formula, all I'm going to have to do is the inverse cosine of whatever my answer is. So this formula can be nice and handy to find an angle using the cosine rule. But we'll have to know that off by heart because it's not in any formula book. So I'm just going to clean this all up. If we want to find an angle, we can use that formula. We can also use the other formula and fill into it and then rearrange. So again, remember, my angle A has to be opposite the side of A. So this one with the minus has to be the opposite side. And angle A has to be between the B and C sides. So we'll look at an example in a minute, but to find an angle, we need all three sides. So we need something like this. And using all three sides, we can choose whichever angle we want, but let's say we want this angle here. We can use the cosine rule to find it. And also, just to remind you, if we want to find a side, we need an angle sandwich, or two sides and the angle between to find the opposite side. So, let's do an example. I will do this example using my new formula. So, cosine of A equals b squared plus c squared minus a squared over 2bc. So let's label. First of all, my angle A is this one. So this must be side A. And then that means that could be B and that could be C. So the cosine of the angle I don't know, so theta, is equal to b squared, so 11 squared, plus c squared, 6 squared, minus a squared, which is 8 squared, over 2 times b, which is 11, times c, which is 6. Okay, again, at this stage, I can put all that into my calculator, but I also need to split up the cosine of the theta. I want just theta, so I need to use the inverse cosine of all of that stuff. 11 squared plus 6 squared minus 8 squared over 2 times 11 times 6. So now I'll put all of that into my calculator in one go. So cosine of theta, then I have a fraction, 11 squared plus 6 squared minus 8 squared. And on the bottom of the fraction, 2 times 11 times 6. And remember to close your bracket at the end. And I get theta is 45.207. A few more decimals. Again, there's no decimals specified in this question, but I personally like to go for whole numbers in angles if I can. So theta is around 45 degrees. So here is an example for you to try. Pause the video again and give it a go yourself. I'll start labeling. This is angle A. This is side A. So then this can be B and C. So the cosine of my angle, which is theta, is equal to b squared plus c squared minus a squared over 2 times b times c. So I want theta by itself, so I need to use the inverse cosine. And all of that stuff can go into my calculator. Inverse cosine, press the fraction button, 7 squared plus 10 squared minus 9 squared over 2 times 7 times 10. And close my bracket at the end. And I get 60.9407. Or, again, if I want to round, approximately 61 degrees.